Welcome to the day one of Snowflake data engineering. So yesterday, I thank everyone who has taken time for joining the demo session. Okay, but within the session, I just told you what is Snowflake, why should we use this Snowflake, and what are the high-level features of Snowflake, and what is really required to get trained in Snowflake. These are all the high-level points we have discussed. Okay, but today is the day one. I just want to get back into yesterday's one content, that is Snowflake definition, what exactly is required, and why should we use this Snowflake, and how the modern computing environment has evolved, and with respect to Snowflake, what is the advantage and the benefit that we can use in order to use this particular Snowflake? Those things we'll discuss. And then one thing what I have told you is Snowflake happens to be a cloud-based data platform, right? When I told you something like it's a cloud-based data platform, what we'll be doing is we'll be learning about cloud. We'll be learning about data warehousing for the first 2-3 days, and then we'll be combining or blending the concepts of cloud come data warehouse combo. And then what we do is that we'll start working on the Snowflake. Okay, so by this Friday, Friday Indian time, and sorry, Friday US time, and Saturday Indian time, we will be able to create a Snowflake free trail environment, and then we'll start working on these particular things. Okay, so without wasting much of the time, let me go ahead and then start up this one here. So when you start doing something like what is this Snowflake here, you can see here. First thing what I have told you is a Snowflake is a efficient storage and analysis system. That means that it is basically a data warehouse that supports your reporting, analytics, and advanced analytics. Reporting, analytics, and advanced analytics. Okay, and what it also does is it also supports the huge large amounts of data, in the sense something like it supports not only the terabytes or petabytes of data, it can also have the option of supporting exabytes of data also as well. So it is a high-tech warehouse where the company can store all its data. Okay, be any domain. In case if you are working in a claims domain or an insurance domain, you'll be having the policies, you'll be having the premiums, as well as you'll be having the claims data, reinsurance data. All that information can be stored. The adjusters and the underwriters information can be stored in that particular place. Okay. Similarly, in case if you are in a sales CRM domain, that tables and all that information can be stored. If it is in a healthcare, we can try to store all that particular information. So this is basically a gigantic data warehouse, not built on premise, but that is something that has been built on the cloud. That's why it is a cloud data warehousing platform. It is basically treated as a cloud data warehousing platform. And the second thing that I discussed here is told you it is not a regular data warehouse, but this is a magical data warehouse. The reason why this is a magical data warehouse is it is in the cloud. Unlike the traditional data warehouses that are existing in your own data centers or in the physical buildings, the Snowflake warehouse is in the cloud. The reason why it is in the cloud is it is not limited to any specific cloud platform. Like when you talk about Azure, Amazon Web Services, or Google Cloud, Azure, Amazon Web Services, or Google Cloud, what happens is those are all cloud service providers. But this is something that uses those cloud service providers in order to build your data warehouse. That's why it is in the cloud. Okay. And the second thing is that you don't have to worry about running out of space or buying more servers. You don't need to do anything in this particular platform. The next thing is that it is super fast. Super fast in the sense, even when you try to run a query against terabytes or petabytes of data also as well, okay, because of that heavy operating system environment, it would be able to run your queries within a very faster time. At a rocket speed, it will be able to run those particular queries. That's why it is a super fast environment that we can say. And the next thing is, it can handle tons of data. I have told you, right? It can have the option of storing enormous petabytes of data also as well, even a whole room of full of computers also as well. It is a warehouse that can hold infinite number of shelves. That is a virtual thing basically. And the next thing is that it is super smart. I'm talking something like it is super fast, it is magical, as well as it is super smart also as well. In the sense, today, assuming that you have deleted some tons of records you have deleted, okay, after 30 days, you want to retrieve that particular data. Okay, even though the data is deleted, it can have the option of retaining that particular data and then give you that particular data. So you can have that time travel feature that exists in this particular case also as well. Okay, so yes, it's time travel. Thank you. Now, another thing is that these are all the features that makes Snowflake a special platform that is being used by every industry right now. Okay, when you talk about Siemens, when you talk about Citibank, when you talk about the major Deloitte consultants and all those things, they're trying to have this particular Snowflake, especially Disney also as well. They're trying to have this Snowflake expertise as a practice. They're planning to develop a lot of practitioners within this Snowflake environment. This is basically what is a Snowflake. So, yeah, as a layman, if somebody is going to ask you what is the purpose of using a Snowflake, the first thing that you need to tell about them is it is basically a cloud-based data warehouse that can be used for your reporting and analysis. That is one thing that you want to tell. And a couple of things that I have told you here yesterday is when you go to this place, I told you, right? It is a modern computing platform. In the traditional environment, you need to use a lot of tools. Suppose if you have seen the job descriptions, if you have seen the job descriptions, what happens is when you see a big data professional job requirement, you have to see a lot of technologies and the skill set that are really required. Okay, and again, when you have this data that is coming from the different sources, and when the data is being consumed by these different users, automatically what happens is that you have to go through a lot of transition using this integration, transformation, normalization, and data analytics in order to reach the consumer. So that means that there is a lot of development time, there is a lot of learning curve, there is a lot of technologies that are involved, and then there might be different silos of data that really exists in order to make your data redundant, duplicates, junk data exists, and then the data, when it is spread across multiple places, it happens to be a junk, because the same data exists in data warehouse, it exists in data marts, and it also exists in backups. The same data exists in cubes also as well. The same data you'll be using for file sharing. Okay, the same data also will exist in the data lake also as well. So Kamalakar, is it not something like when you're trying to keep all these multiple copies of the same data again and again, is it not something like updating the
Redundant.
data? Yeah, it is redundant, and updating the data is always happens to be a problem. Along with you will not be able to appreciate the efforts of this particular architecture of the traditional data ecosystem. Traditional data ecosystem. That is the reason what I prefer to do is that I prefer not to store the data in these multiple platforms like this, but instead I want to move on to a modern computing architecture, modern data platform. Okay, this modern data platform, what you're seeing here is basically the modern data platform. What you're seeing here is basically aimed at is basically aimed at trying to keep only a single copy of the data. And we don't use that many ETL tools and reporting tools for the purpose of procuring that particular data. Instead, what we do is that we try to keep this particular data with the help of a single type of ETL and streaming part for getting this data here. Similarly, of course, you can use different types of reporting tools like Tableau, Power BI, Python, and all those things for connecting to this Snowflake, and then you can have the option of getting that particular data also as well. Okay. And one more thing that I have told you here is that Snowflake doesn't happens to be a data. Sorry, Snowflake doesn't happens to be a cloud provider. It is not a cloud provider, right? Cloud service providers are something like your Google Cloud along with your Amazon Web Services, and then this is your Azure. Okay, but on top of that one, you're going to build a cloud platform, cloud data platform. That data platform happens to be your Snowflake. Okay, that's why Snowflake doesn't have any infrastructure on its own. Okay, it doesn't have the memory as well as which format of data is being stored in Snowflake. Thanks, Susmita, for the good question. Snowflake happens to be a relational data warehouse. That's why all the data that we use in Snowflake happens to be stored in the form of tables only. Happens to be stored in the form of tables only. And for the purpose of doing your ETL related activities, for the purpose of doing your reporting activities, for the purpose of doing your data definition and all those particular things, you use only the Snowflake SQL, which is more like the normal SQL what we use in your relational databases. That's the reason Snowflake stores the data only within the relational format only. I hope that answers your question, Susmita. Okay. Now the next thing, yeah, hi.
This is Gopal Ravi.
Yeah, hi. Gopal, okay. I'm sorry. So I thought it is Susmita.
There's a
Yeah.
small question here.
Okay.
So we can have here like many things like structured, unstructured, semi-structured. So which one it follows?
Snowflake follows only structured and semi-structured data. Okay. It does not have the option of storing unstructured data. It doesn't have the option of storing that unstructured data. So for the purpose of storing that unstructured data into this particular Snowflake, what you have to do is that you have to use a couple of different workarounds in order to take the structured data out of our unstructured data, put it into a tabular format, and then only you can store. That's why Snowflake doesn't support unstructured data. Does it answer your question, Srinivas?
Yes, anyhow that you're going to cover, right, in the class?
Of course, we are going to cover the variant data types also as well. Variant data type is there in Snowflake that covers this semi-structured data. But how we can have the option of bringing that unstructured data, converting into a structured form, and then storing it, that one we'll be using a use case scenario in the sessions also as well. Okay, Srinivas?
One more question, like today we're attending. Only the Snowflake training, or any apart from this, any other training you're going to give? I mean, like other technologies, DBT or some other things.
DBT we are not covering in this one, sir. It is only pure Snowflake, end to
Only
end.
Snow.
Yeah,
Okay.
end to end
Okay.
you are covering. Okay,
Thank you.
no problem, sir.
So the Snowflake at the end, like you mentioned, that it's a relational database. So at the end, the data is going to be stored in the
Form of
columnar
tables,
format. Okay,
relational format, relational format. It is
okay.
going to be stored within the relational format, and then it is being stored only in the tables, just like in
So
your
in that case,
Oracle.
what makes the real difference compared to the traditional Oracle data warehousing or any SQL Server data warehousing compared to the Snowflake data warehousing? So said that I mean, though it's a cloud-based data warehouse platform, other than that cloud-based, in terms of the storing the data, it's all same RDBMS uh, techniques, which it still follows, right? Even though it resides in the cloud, or is it?
Let me tell you one thing here.
Okay.
in case if you are creating Oracle data warehouse, is it not something like you need to be worried about the RAM? Is it not something like you'll be worried about the storage? You won't be worried about the memory outages. Okay.
Scalability, which you are referring here,
The
right?
scalability and elasticity. Those are all the features that won't be available on on-premise environment, right? Basically. Okay. And even though when you use your Azure or AWS also as well, there what you need to do, you need to set up your virtual servers, right? The EC2 machines and all those things you need to set up, right? You need to be responsible for doing the patches for your operating system and your databases also as well, right? Okay. And you need to be worried about how to replicate your data using multiple backup copies and all those things you need to be worried about, right?
Yeah.
Okay. And these are all the things that comes under infrastructure as a service and platform as a service, right? Okay. So Snowflake is not an infrastructure as a service or platform as a service. It is a software as a service. Okay. Leaving all the details of the maintaining the infrastructure, okay, worrying about the storage, compute, networking, redundancy, failover, and all those particular things, what you can do is that you can simply focus on your application and the rest is going to be taken care by Snowflake. That's the reason I told you it is a magical data warehouse.
Okay. And one more question is that do we have that any I mean, maybe it may not be irrelevant since any other Snowflake type of tools or cloud-based data warehousing systems which is
We have
available
this
in the
Azure
market.
Databricks. You have Azure Databricks that is available.
Okay,
Databricks.
similar kind of.
Yeah.
Thanks, Ravi.
Okay. Does it answer your questions here? Thank you so much for these relevant questions. These are all relevant. Okay. Now, so I told you the difference between a previous traditional data architecture and this modern computing platform. This is the way this is going to be there. It's going to be a cloud-based existing on these three types of cloud service providers. That's why Snowflake is not a cloud. This is a data warehouse that exists on the cloud. This is the data warehouse that exists on the cloud, and that cloud can be in any of these things. It can be on AWS, it can be of Azure, it can be of anything for that particular matter. Okay. So one thing here. Now, as I have told you, right, since it is going to be a single copy of data that is being stored in this database or the data warehouse, you will be able to do all these particular applications. So somebody was asking, right, can it store unstructured, or I think Gopal is asking, right? Can it store unstructured data? It cannot store unstructured data. It can have the option of storing only structured and semi-structured data. Okay. And it can do that ELT and ELT. We'll be doing all these things. It can do this data sharing. It can be using this multi-clustered environment. And then I was telling you something like Sai, I think, where is that Sai? He's mentioning something like time travel. This time travel is going to be a good feature that we need to use within Snowflake. We'll be using this one. And then the DevOps, all these particular things that exist. So 2014, I have told you, like, it has created this one in the cloud. Okay. And then from then what it does is that the data cloud connected all the data regardless of the regions where you are in. So it became global in 2018. Then in the next case, what it has done is that it is trying to use all your third-party marketplace applications in order to make this comfortable here in this particular place. So this is what is Snowflake that is making you one minute. That is making you unique in this particular program here. That is making you unique in this particular program here in this case. Okay. Now, benefits we discussed, but we'll be discussing once again. But as I have told you, initially, the data journey with respect to Snowflake happens to be on-premise enterprise data warehouses. Like the other friend is asking, when you have your Oracle data warehouse implicit on-premise, this is the way. Then we have this first generation Hadoop big data analytics has come into the market. big data analytics has come into the market. Okay, and then we have this public cloud that has come where instead of implementing your enterprise data warehouse on-premise, it has moved to this public cloud here also as well. Okay, and then the data lake house has come into the picture, and finally where we are ending within a Snowflake environment. Within the Snowflake environment, it is something like it exists at single engine, globally connected, self-managed, and then it is having the marketplace where you can have the option of using the third-party integrators for the purpose of getting this particular data also as well. So these are all the things that we are going to use in this particular curriculum basically. Okay, so one platform optimizes storage, structured. See, it says that it is unstructured, but it is only semi-structured and structured only basically. Okay, these are all the things that we'll be using in this particular platform. Okay, powering multiple workloads we discussed basically. So the takeaway from yesterday in terms of demo is I was telling you, Snowflake is a data warehouse. It is not a transactional system. It is not a transactional system. Means it is not a sales processing system. It is not a banking system. It is not something a claims processing system. It is an analytical system. That means that the data that you store within the Snowflake can be used only for reporting and analytics only. That is the first thing. And second thing is it is cloud-based. So if anybody asks you, is Snowflake a cloud? Snowflake is really not a cloud. Snowflake is a data platform. So when Snowflake is a data platform, obviously what happens is within the data platform that should exist on any of those three cloud service providers: Azure, the next one is AWS, and third one is Google Cloud. These are the three things that we are going to use, and it is a software as a service. Software as a service that I have told you.
Snowflake database database cloud.
Huh? Somebody is asking something. Oh, Snowflake database. Okay, so I told you these are all the different skill set that is required here. You need to be good at SQL. Somebody was asking me, like, Sai, in what format the data is being stored? The data is being stored only in the relational format. That's the reason what we do is that we use only the SQL. SQL, you have to be good. And then we'll be using, I don't teach the SQL from the basics, but wherever it is relevant, where some of the SQL queries has to be explained, I'll be doing that one. And then this will be, I'll tell you one thing, like if you are doing something like A, B, C, D, without knowing ABC, I don't go on to D. Okay, I'll just make sure that you are comfortable with respect to the SQL, what is being used in this entire Snowflake course, and then I'll take up the things. That's why rest assured. We'll be doing with respect to the Snowflake architecture, which is really important, which will be having three types of layers. Data modeling we'll be doing, and the major part what we'll be working is on this ETL part. So it doesn't matter where your data exists, either in on-premise or else it is in the cloud, whether it is a batch data, whether it is a structured, semi-structured, or continuous real-time data, we should be capable of developing efficient ETL pipelines for the purpose of doing your data conversion and then put it into the data warehouse. That particular part we are going to do. So the ETL and data integration are going to be the same thing that we are going to cover. I hope, Srinivas, you are following. Sridhar, you are following. Sai Garu and Susmita is that Gopal, right? Yeah. Okay. And one more thing, that security and access control is really, really important. The reason why they happens to be really important is nowadays you have been seeing many of our data systems, applications, and everything is being compromised. Fake accounts are being created and fake transactions are really happening. That's the reason we need to have some stringent security controls that need to be used in order to safeguard our data, our applications, and your company. Because the whole company's data or the information assets are being putting in the cloud. That's the reason what we need to do is that we need to make sure that we get this data in control in order to safeguard against all the malpractices that we use within this Snowflake. So these are the skills that we are going to have, and we'll be learning all these particular things also as well. Okay, and the next thing I discussed yesterday is this one. It is going to have a learning curve, I have told you, right? So we'll be working on that learning curve also as well. So I hope everybody is good with respect to yesterday's demo. In case if you have any questions, please let me know before I go ahead and then start the first day one concept, which is the cloud computing within Snowflake. The schedule is like this. Today and tomorrow I'll be covering this cloud computing concepts to make you familiar. What are all the inputs that are really required for this cloud computing? I'll be discussing that one. And tomorrow and day after tomorrow, we'll be discussing about the data warehousing concepts, because Snowflake happens to be a cloud-based data warehouse. We'll be discussing those 3 days will be dedicated to make you comfortable with respect to those particular concepts. Okay, to make you comfortable with respect to those concepts. So we will be working together to make sure that you are totally comfortable with respect to these particular things in order to start our journey with respect to Snowflake starting from Friday. That's what we are going to do. Before I go ahead and then start these cloud computing concepts, in case if you have any questions, please let me know. I'll be able to answer. Hopefully. Are you guys comfortable? At least say yes in the chat window, sir. See, I encourage this class to be interactive as much as I can, because I really want to understand your background, as well as you need to understand my background, so that we'll be able to work together in order to fulfill the career goals what you're having here, basically. So that's why I prefer every class to be interactive, and then if you can at least a chat within the window, that would be great and appreciated. Or else, in case if you have a question that you want to ask, like the way Sridhar has done, you can also do that one. Sridhar or Srinivas, I'll appreciate that one too. No questions?
One question, Ravi.
Yeah.
How it is different from the Azure Synapse Analytics?
Yeah, Azure
I
Synapse
get it.
happens to be your platform as a service, right? Basically, it is a platform
Yeah.
as a service, right? And here, this is software as a service. We'll be discussing what is the major difference between platform as a service and software as a service, and then how that is going to be differentiated from that Azure Synapse and AWS Redshift and Redshift Spectrum. We'll be comparing and contrasting the differences, and then we'll be discussing that one in the next class, guys. We'll be discussing that one. Okay.
Okay.
Yeah, hi Ravi. I'm having one question. Yeah, yesterday I have not attended the demo. This is my first class regarding.
Okay.
Yeah, do we need to get the basics of AWS Azure like that? Currently, I was working for in Pega technology as a Pega developer. Yeah, just I'm interested regarding this. Okay, what are all the basics which I need to get started this?
No basics are really required, sir. No basics are really required, because what are the basics that are required for the cloud computing, and what are the basics that are really required for the data warehousing concepts? I'll be covering this next 3 days. Okay, that itself will be the prerequisite in order to start the journey with respect to Snowflake. Does it answer your question?
Yeah, got it. It means after completing each class, it means do we get the recordings, and apart from the recordings, what else we'll get? It means the screenshots or the notes which you'll prepare, you are going to share with us.
Of course, of course. That is
Okay.
right. That is right. So everyday session recording happens to be in the Zoom cloud. So as
Okay.
soon as I get that recording, I'll share it to everyone. Okay, and then you'll be getting that particular recording. That is one thing. And second thing is that the slides and the case studies and the assignments will be shared to you also as well. Okay, and Snowflake is having something like Snow Pro core certification is there. Snow Pro core certification. So
Okay.
that particular thing also will be discussed, and then the material in order to make sure you complete, you do that particular certification is also going to be shared with you also as well. Okay.
Yeah, okay, got it. Yeah, just I was very curious. Okay, how is the market in US currently for this Snowflake?
Market is really good. I told you, right? Every company who is a tech savvy is really looking for starting a practice and some practitioners within Snowflake. And nowadays, this is happening as a mandatory, and then we are seeing a lot of traction that is happening with respect to the openings and the job requirements with respect to Snowflake. Not only for Snowflake, for any data engineering jobs also as well, we are seeing a lot of traction in this one. Okay.
Okay, got it, got it. It means if you take any technology like Java or Pega, there will be more number of developers in the team for Pega as well for Java and .NET as well. Okay, can just I was curious for the Snowflake developer. It is an development. We are going to work as a software developer, or we are going to be part in the admin team.
You are going to work as a data engineers.
Data.
You'll be
Oh,
working as a data analyst. So I really don't know how much you have made your mind to learn this particular Snowflake, but here we don't use the terminology of developers, QAs, and all those particular things. The end-to-end, the ETL development, who does, they're basically treated as data engineers here. Okay.
okay.
And
Yeah,
then you'll be working as a data analyst, and then you'll be working as a lead data architect. Okay. Or else
okay.
you'll be working as a data analyst. So here, anything what we do is something that we talk about data only. Okay.
Okay.
We do a lot of research and analysis with respect to the data. That's why you'll be treated as a data something here in this
Okay.
case.
Okay.
Okay.
Okay. Yeah, got it.
Cool.
Yeah, I'm good. I'm good. Thank you.
Any other questions?
No, as of now, I'm good. Yeah.
Are you able to cover the Power BI, Ravi?
Good question. Who is asking that question? Mandal Ravi, right?
Yes.
So here, what we'll be covering is I'll be covering Tableau connection with respect to Snowflake, along with Power BI connection with respect to Snowflake also as well. I'll be covering. Okay, there are some Snowflake ODBC drivers that you need to install on your laptop. Okay, and then making sure that you make the ODBC connection to that Snowflake and then get the data and then do all these visualizations and all. I'll be showcasing you either on Tableau or Power BI. Okay, if I show it on Tableau, I'll tell you the links how to do it with respect to Power BI. If I do it on Power BI, I'll tell you the links for Tableau. Both are one and the same basically. Okay.
Hey Ravi, I have
So-
a question. So, how is
Sure.
this different from MongoDB? And I also see that's like only 30-day trial for Snowflake, right? So,
Let me tell you, Sahaja, the thing is, every 30 days, you need to create a new trail. Okay, the reason is when you create a 30-day trial version using one Gmail ID, one email ID, what happens is you'll be given $400 credit worth of credits. Okay, the moment either you consume them or within 1 month your thing expires, and then you need to use our separate new email ID and then create one more account. That's how we need to start doing the theoretical learning path with respect to Snowflake. That is one thing. And second thing is that Snowflake comes up with standard, enterprise, business critical, and another VPS edition that comes. Okay, so while you're trying to create this particular Snowflake, it is always advisable and encouraged to use this enterprise edition, because what are all the features of Snowflake that we are going to cover, okay, will be tested, learned in that particular enterprise version. So that's why, since this is going to be a 40 to 45 day classes that we are going to have, there is always a chance that we need to create one more free trial edition in order to cover all these particular concepts, Sahja. That is one thing. Okay. And the second thing is you're asking about MongoDB and all those things, right? They happens to be your MongoDB is a NoSQL database, right?
Yes.
Yeah.
MongoDB is a NoSQL database, but this is a relational data warehouse, SQL-based data warehouse, basically. Okay, so it only understands only SQL. So since from our education and graduation and from our initial career perspective, we got to work only on the SQL part. Your job becomes easy when you start developing these ETLs and all those things with respect to the SQL code only. That's the reason it is going to be distinct from apart from the other databases what you are having here, Sajja. Does it answer your question or any other questions you have?
No, thank you.
I have a small question, Ravi.
Mm-hmm.
How about the project?
Sorry, what is your question?
Project at the end.
Okay, so good thing. So we'll be covering all the chess pieces of your data engineering with respect to the Snowflake features. We'll be covering everything, and once all those particular concepts are completed, we'll be discussing that case study for 3 days, end to end, including procuring the data from your sources till you load the data into your data warehouse and then do the reporting and analysis using Tableau, Python, or Power BI. Everything is going to be discussed, and then you'll be given the data, the simulated data that you'll be given, and then you'll be asked to implement all that particular hands-on. We'll be doing that one. An end-to-end project will be doing this one here, Srinivas.
Yeah, great.
See, this thing will be greater in case if you also contribute to make sure that you will also spend some time every day to do this hands-on, go through the lectures, and then do this social networking, communicating with the teams, so that things would be more greater here. Basically, I'm ready to do that part, and I encourage you to do that one also as well. Can you do that one, sir? Okay, that's how these things are going to be discussed here. Now, so I'll start off in the next 10 minutes. What I do is that I'll start with the cloud computing concepts and then we'll continue. Requesting everyone to join by 6 o'clock sharp Indian time and 7 o'clock, 8:30 sharp EST time here. Or whoever are there in the time zones, please try to join so that we can try to cover as much as we can. So this is what is your cloud computing overview. Okay, so when we want to appreciate the new modern ecosystem, first thing what we need to do is that we need to go back and then see what is there in the traditional system. What is there in the traditional system? So I don't want to speak and then I want people to speak here. I want people to speak. Yeah, see here, this is your traditional system. What is your traditional system? So here, what you're having is you have your corporate data center. Within this data center, either you own this corporate data center or else somebody else lease this corporate data center, and then you keep all these servers here. Okay, you have the storage servers as well as you have the backup system. You have all these routers, switches, firewalls, and all those things will be there. And this is like this. This is what is your capital intensive. That means that even before you think of implementing a project, obviously what you have to do is you have to spend a lot of money, some thousands and millions of dollars that you need to spend in order to set up this corporate data center. So that means that the capital expenditure is going to be more in the case of this. The capital expenditure is going to be more in the case of this. In the case of this traditional IT environment. Okay, now where are you sitting? You'll be sitting in this platform in the corporate office, and then you need to connect to your data center and then start working basically. So this is your data here basically that happens. Okay, so this is what is the happening with respect to the legacy and the traditional IT environment basically here in this case. Legacy and the traditional IT environment that you generally work with here. Okay, so that means that IT staff, there will be something called as the technology services department or the infrastructure department should be able to build, operate, and then manage this particular equipment. So can anybody tell me what are the drawbacks of this current thing what we are discussing here? What are the drawbacks?
It will more
Upgrades.
costly and more time taking and more
Maintenance issue.
like volumetric storage. Okay, we can able to control it with easily with the cloud.
Yeah. See, the major drawback what you can see here is these servers, once they become outdated, what you need to do? You need to scrap them, right? Basically. Okay. And the thing is, suppose if you are working on, you are having an iPhone which is 14 version that is there. Okay. So if the 15th version of iPhone 15 comes in the market, what will you do? Will you still keep your 14 version? You don't keep that one, right? You go ahead and then trade your
Upgrade.
phone and then upgrade to 15. At least you get some money when you trade in, but nobody will be able to care these. Suppose when you go and then try to share these things, sell these particular things to a different vendor, he says, "Bro, I don't care," because he really don't care about the type of infrastructure what you're having. Everything what they want is the new. So that means that the total expenditure that you have spent on this IT infrastructure has to be written off, and then you need to purchase new thing because you are owning this particular equipment. Okay, if you have not owned this particular equipment, if you have leased or rented this environment from somebody else, there is no need for you to spend lots of thousands of dollars on capital expenditure. Instead, you can start spending on operational expenditure. That is what is treated as OPEX. That is what is treated as OPEX in this particular case. Okay, that's the reason in the legacy traditional environment, what you're having is the data center building, either purchasing or leasing is a cost, security is a cost, physical IT hardware is a cost, licensing is going to be the cost, power, internet connectivity, the wages, everything is going to be a lot of cost that is involved within this particular architecture. A lot of cost that is involved in this particular architecture here in this case. Okay, now that's the reason what we want to do is that we want to go on to this cloud computing. Okay, so when we really want to go on to this cloud computing, what exactly we need to do is we need to do these things. For example, what you need to really do is we need to mention like I don't own anything. I don't own anything. Everything is available or owned by somebody else. That somebody else happens to be your cloud service provider. Okay, the only thing that you need is you need to have an internet connection, you need to have a laptop, or else you need to have a mobile phone. Even from the mobile phone also as well, you can have the option of connecting to that particular resource. What is that resource? The resource might be memory, the resource might be computer, the resource might be storage, the resource might be anything for that particular matter. Okay, you need to connect to that particular resource. Okay, do all the crazy business what you want to do. The moment once it is completed, what you can do is that you can pay for the service what you have used, and then you can come back. That is what is your cloud computing. That means that on demand utilization of resources, pay for what you use, and then there is no need for you to think about how much is the capacity of your servers. All those particular things, there is no need for you to think about. That is what is your cloud computing. So you don't own anything. You don't own anything. Everything happens on demand. Okay, there is no need for you to suppose if you are using a computer or a desktop which is having 10 GB of RAM, when your process need to process more amount of data, if the 10 GB of RAM is not sufficient, you need to purchase another hardware also as well. But here there is no need for you to do all those things. Everything happens to be on demand. They are dynamic. And then you'll be able to utilize them in this particular process. That is what is cloud computing. So if you want to see the differences between this cloud computing and all these things, this is an on-demand self-service. That means that what is this on-demand? Can anybody tell me what is this on-demand? What is this on-demand? This on-demand is
use it like you can request it whenever you need.
Yes, ma'am. Yeah, we can use it whenever we need. That's it. Like when you're going on a railway platform, okay, in case if you want to drink a cup of tea, you go there, order for the tea, pay it, and then come back. Those are all the resources that we can use. We can use it whenever we want. That is on demand. Okay, and self-service. Okay, in the traditional IT thing, what you are doing here, what I have told you here, there should be some IT staff. If you don't have the IT staff, your work cannot be done on that particular day. You have to request, they need to get the approval, they need to purchase something, and then they need to get it. They need to configure, test, and then they will tell you. So all this particular process will take so much amount of time in order to give that particular product. But in the case of this one, it is a self-service. You yourself will be able to procure the compute systems, procure the operating system, memory, and everything. You should be able to configure, you should be able to use them, and then without having any help from the infrastructure. That's why it is always a self-service. And one more thing is that I told you something like it is a measured service. You pay for what you use. You pay for what you use. So if you don't need it, you don't pay for that one. Okay. Now suppose my friend Kamalakar has purchased a Apple 15 version, okay, which is having a 512 GB or 1 terabyte of memory. Is it that he is really using that 1 terabyte of memory? We don't know. Maybe he'll be using something like 250 GB of memory, but other 750 what you're having here will be waste. It is an expense. It is an expense. Here, there is no need for you. Here, in the case of cloud computing, there won't be any concept of wastage of assets. There won't be any concept of wastage of assets. That means that you will be liable to use what you are supposed to use. You will be liable to use what you are supposed to use. That's the reason this is treated as a measured service in the case of cloud computing. And elasticity. So I'll tell you one thing about elasticity. Like not today, maybe tomorrow I'll tell you. In the case of this elasticity, what you need is that suppose today what you're doing is that you're having a less traffic and then less sales that are happening. That means that you don't need that compute power, more compute power. But tomorrow on Black Friday, assuming that you're having more sales that are happening, then you need more computing power. So that means that the computing power or the storage is not going to be same across the whole year, right? There will be spikes, there will be downs, and everything will be there. Okay. Now, in the case of elasticity, what happens is when you try to take a rubber band and then stretch it, it expands. And when you don't need it, what you do is that you try to compress, right? So that is what is called as elasticity. That means that if you need something more, it will be provided automatically. If you don't need that one, you can release those systems. You can terminate those particular systems. So that happens automatically. That's the reason they're treated as a rapid elasticity in this particular case. Okay. Here, when you purchase that computer system, in the case of this traditional IT, you will be owning this particular environment. You'll be owning this particular environment. But in the case of this cloud computing, what happens is that not only you will be utilizing your computer or your memory, but many people across the globe can have the option of utilizing that particular memory also as well. Many people can have the option of utilizing that particular memory also as well. That is the reason what we say is that this is resource pooling here. When you say something called as resource pooling, what happens is that not only that you are going to be the owner of this particular resource, but cost, no resilience in the case of disaster. I talked about that one. Yeah. So when you have more people who will be utilizing that resource whenever it is really required, that is what is your resource pooling. But here you happens to be a single tenant. You will be the whole authorized user of this one in the case of the traditional IT. Okay, so I'll stop here for today, making sure that we just started what are the features of Snowflake, and then how it is going to be different from the traditional data warehouses or traditional cloud computing platforms we have discussed. And we just started, since Snowflake happens to be a cloud-based data warehousing platform. Okay, we started discussing these cloud computing concepts, and then what we do is that we will go ahead and then we'll start working on this further concepts tomorrow and day after tomorrow. And then by day after tomorrow, I think you should be completely comfortable with respect to the cloud computing and data warehousing concepts. And then from Friday onwards, what we'll be doing is we'll be starting the features of Snowflake by creating a trial version for 30 days on an enterprise platform. Okay, we'll do that one. So I have next 2 minutes of time. In case if you have any questions, please let me know. Otherwise, from tomorrow or day after tomorrow onwards, what I do is that I'll drop my number and WhatsApp ID. In case if you have any questions, you can reach me out. Okay.
How about timings? Regular timings.
Regular timing is the same time here, 6 to
6
7.
to
7.
Okay.
Okay. So still I have 1 more minute left, and we'll discuss tomorrow.